Welcome everyone to part two of the bootcamp for students. If you didn't join us for part one, hopefully you saw the email that directed you back to the YouTube video and recording, which you will have access to and be able to watch, as well as the GitHub repo. Um, so obviously part two is going to build on part one. You will, however, need to, if you haven't done so already, sign up for your Elastic Cloud trial. So if you're a student with an EDU or AC email, you will get 30 days. If you're a student without, no worries, it will just redirect you to 15 days, which is plenty of time to take you through the rest of the workshop. So the QR code is there. That'll take you right to the site to sign up. And so just take you just a minute to do that. You can do it while I'm talking if you haven't done so already. Thank you, once again, everyone who stayed up late. I know we have some people at 2 a.m., 3 a.m. That's amazing. And welcome to all of you who just took time out of your day to participate. We think this will be a super valuable just experience for you and kind of building that solid foundation of understanding. We do have one more session after this that Phoebe will talk about next week, and that will be our third part. That's also where we'll be drawing for swag. So if you haven't registered yet, we'll include that link at the end as well. And just as a reminder, we will send out the recording for this following the close of this presentation. Just a couple of housekeeping items. If you haven't done so yet, make sure you do sign in with your first and last name. It's just nice for us to see who you are. Just remember, I don't even think you have permission to talk, but just mute your mic just in case so we don't have background noise. And then of course, sign up for your free account. This is all brought to you by the Elastic Students and Educator Program. So just kind of serving you and helping to support your learning of Elastic with kind of free resources and trainings and whatnot. If you have any questions, I think my email is in the email that you received, but it's also right here and I'll put it in the chat. So you can always reach out to me directly with any questions or need additional support or anything like that. We're always happy to help. But I don't want to take away any more time from our presenter, Lisa, today. So I am going to turn it over to her. Phoebe at the top will also be monitoring your questions in the chat. So do make sure if you missed that to change the two in the chat panel to panelists and attendees so that we can read your chat and your question and we can get it answered. Lisa generally will wait till the end to answer those questions, but the ones that Phoebe can field, she'll just do intermittently throughout. And then we'll have a Q&A following the presentation. So if you have to leave at any time, totally understandable. Once again, you'll get the recording, no problem. So thanks again for joining us. I am going to turn it over to Lisa. So go ahead.
All right. Thank you so much, Stephanie. Hi, everybody. Welcome to part two of the Elastic Student Bootcamp. I'm Lisa Jung, and I'm a developer advocate at Elastic. So last week, we kicked off this bootcamp, and it consists of 3 workshops that delves into Elasticsearch, Kibana, and Elastic App Search. So by the end of this, you'll know what these products do and when and how to use these products. So during part 1, we talked about the exciting use cases of the Elastic Stack. Then we dived straight into the architecture of Elasticsearch. Then we performed CRUD operations with Elasticsearch and Kibana. And today's workshop builds on the content of part 1. And if you missed the first one, not a big deal. The links and the links to the video recording and the repo of the first workshop have been emailed to you on Monday. So check these out if you don't understand some of the concepts that we go over today. So before we get started, let's do a quick recap. So if you are a developer working with data, the Elastic Stack is a great tool to have on your belt. The stack consists of 4 products: Beats, Logstash, Elasticsearch, and Kibana. And with the stack, you can take data from any source in any format, then search, analyze, and visualize in real time. So today we'll focus on Elasticsearch, which is the heart of the Elastic Stack. And this is a search and analytics engine that powers a lot of the apps that you use today. So for example, if you have ever searched for a restaurant on Yelp or searched for groceries on Instacart, Elasticsearch is the engine that is powering that search. So search is an experience, and whether you're searching for a documentation or your favorite show, you expect fast and relevant results no matter the scale. Now, in the first workshop, we talked about how Elasticsearch allows you to get fast search results at scale. And today we talk about the relevance aspect of your search. So we search for things on a daily basis. And as developers, search is our lifeline, right? So whether we're fixing a bug or building a certain feature, we go straight to the search bar, hoping that someone shared the solution online. And it's really frustrating when you're searching for an answer and you're not quite getting what you're looking for. And that is what relevance is all about. So when you search for something on your app, you want results that are directly related to what you're searching for. Which brings us to the question, well, how do we measure the relevance of our search results? Now, the two factors that we'll focus on are precision and recall. So let's delve into these a little bit more. So as a quick review, we know that Elasticsearch is a search engine, and it allows us to store, search, and analyze data. And it stores data as documents, and documents that share similar traits are grouped into an index. Now, when you search for something, Elasticsearch retrieves relevant documents. Then it presents them as search results, which is highlighted in orange here. Now, on this slide, we have two diagrams depicting the same thing. So on the left, we have documents grouped into an index, and the same thing is shown on the diagram on the right. So the yellow rectangle represents your sample index, and the gray dots are documents contained in that index. And I'm going to use a diagram on the right to explain precision and recall. But before we do that, let's go over some terms really quick. So when you send a search query to Elasticsearch, it retrieves documents that it considers relevant to the query. Now, these are the dots that are inside the white circle. And these are the documents that Elasticsearch sends back as a response. Now, some of these retrieved documents are what you expect to see in your response, and these are known as true positives. Now, you probably had an experience where you searched for something and some of the results were not relevant to what you're looking for, and these are known as false positives. So these are irrelevant search results that were retrieved by the search engine for some reason. Now let's focus on the dots in the yellow region of this diagram. And these are documents that were not returned by the search engine. And some of them are truly irrelevant to the search query and were correctly rejected by the search engine. And these are known as true negatives. Now, among the rejected documents, there may be relevant documents that should have been returned in the response, and these are known as false negatives. So earlier, I've mentioned that precision and recall are used to measure the relevance of a search engine. And the term precision has to do with the dots inside the white circle. And these are documents that are returned as search results. So precision is calculated by true positives divided by the sum of true positives and false positives. So what precision tells you is what portion of the retrieved data is actually relevant to the search query. Now, recall, on the other hand, is calculated by true positives divided by the sum of true positives and false negatives. So what recall tells you is what portion of relevant data is being returned as search results. So precision and recall are inversely related. Precision wants all of the retrieved results to be a perfect match to the query, even if it means returning less or no documents. Whereas recall focuses more on quantity. It wants to retrieve more results, even if the documents may not be a perfect match to the query. Now, the dilemma here is that we want to present really relevant items, but we also want to retrieve as many results as possible. So as you can see, these two factors are at odds with each other, because if you want to improve precision, it might cause a decline in recall and vice versa. So let's recap real quick. So precision and recall determine which documents are included in the search results. But precision and recall do not determine which of these returned documents are more relevant than the other. This is determined by ranking. So when you look at your search results, you'll see that the most relevant results are at the top and the least relevant are at the bottom. And this ranking or order is determined by a scoring algorithm. So each result is given a score. Ones with the highest scores are displayed at the top, whereas the ones with the lowest scores are displayed at the bottom. Now, score is a value that represents how relevant a document is to that specific query. And a score is computed for each document that's a hit, and hits are search results that are sent back to the user. So the higher the score a document has, more relevant to the document is to the query, and it's going to end up higher in the order. Now, there are multiple factors that are used to compute a document score. And for this workshop, we'll only focus on term frequency and inverse document frequency. So let's break this down. Now, when you search for something, you type in a search query in the search box, and Elasticsearch looks at the query and pulls up relevant documents or hits. Then it calculates a score for each document and ranks them by relevance. So how does this happen? Well, let's talk about how term frequency plays a role in calculating a score. So here we have a search query, how to form good habits. And this query is made up of multiple search terms. Now, Elasticsearch will look through the returned documents and calculate how many times each search term appears in a document. Now, this is known as term frequency. So if a document mentions search terms more frequently, Elasticsearch assumes that this document is more relevant to the search query, and it assigns a higher score to that document. So let's say we're looking at the frequency for the term habits, and in the field description of the first document, the term habits appears 4 times. Now, in the same field in the second document, the term habits appears 1 time. So in this example, the first document will be given a higher score and end up higher in the search results. Now, when we calculate a score based on term frequency alone, this will not give us the most relevant documents. And this happens because term frequency considers all search terms to be equally important when assessing the relevance of a document. So let's take a look at the search query here. Now we have search terms, how, and to, and form, and good, and habits. Now, not all of these search terms will help you determine the relevance of a document. So for example, the first 4 search terms are commonly seen in many, if not all, documents. Now, if you take a look at the hits, then at the documents highlighted in orange, these documents like how to form a meetup group or good chicken recipes, they do contain some of the search terms, but these are completely irrelevant to what we're looking for. But because of term frequency, if these commonly found search terms were found in high frequency in any of these documents are going to end up with higher scores, even though these documents are irrelevant to the query. So Elasticsearch offsets this with inverse document frequency. So with Elasticsearch, if certain search terms are found in many documents in the result set, it knows that these terms are not useful at determining relevance. So when it goes through all the hits, it'll reduce the score for documents with unimportant search terms. And it'll increase the score for documents with important search terms like habit. Okay, so we just covered the basics of relevance. Next, we're going to fine-tune precision or recall of our search results. And we're going to do that by sending queries from Kibana to Elasticsearch. Now, in part 1, I shared that there are multiple ways to access these 2 products. Now, one option is to use Elasticsearch and Kibana hosted on the Elastic Cloud. And unlike the downloaded option, Elastic Cloud handles all the heavy lifting of managing the stack, so you can focus on building your product. Now, you get a free 30-day trial, as Stephanie said, and we went over how to get started with Elastic Cloud during the first workshop last week. Now, as promised, this workshop, I'm going to show you how you can download Elasticsearch and Kibana and run these locally on your own machine. So the downloaded option is free without an expiration date, but you do have to manage these products on your own, and there are additional steps involved. And I found that when I screen share on Zoom and show you how to download and run these locally, Zoom slows everything down. So showing you this live is almost impossible. So I create a video for you guys just for this part. Okay. But first, let me share the GitHub repo for today's workshop. I believe Phoebe also shared it earlier already. Now, the link to this repo has also already been shared with you via email on Monday. So click on this link. And when you do, you'll see this on your screen. So this repo contains all the resources that are shared during this workshop. And if you scroll down to the resources section, you'll see the link to the instructions for downloading Elasticsearch and Kibana. Now, this is a blog that includes links to the download pages and step-by-step directions on how you can download and run these products on your local machine. So this video I'm going to show you will breeze over these steps, but if you need more detailed instructions, feel free to check out that link. Okay, so I don't really expect you to set this up during the presentation because I'm just showing you what you need to do. So if you want to try this out on your own, you can watch the recording and get started. So let me just get set up here real quick. Okay, so I'm just going to gloss over the part about running Elasticsearch and Kibana. Now, a lot of you have completed these steps before we started the workshop, and the step-by-step directions on what we're about to breeze through are included in the repo. Now, so far, I have downloaded Elasticsearch and Kibana from Elastic website, and I moved them to my desktop. Now, I've unzipped both products by double-clicking on them. And on your right, what you're seeing is the unzipped folders of Elasticsearch and Kibana. Now, we're going to run these two products by using the command line interface. So let's pull up our terminal. Now, I have 3 tabs open. So the first tab is running Elasticsearch. So I just CD'd into Elasticsearch, which is located in my desktop. And then I ran the command bin/Elasticsearch. Now you use this command if you're on Mac or Linux. And if you're on Windows, you run bin/Elasticsearch.bat. Now, if you are following my blog to learn how to run Elasticsearch on Windows, you could just run Elasticsearch.bat. Okay. Now, click on your terminal and hold Command F, and we're going to look for 9200. Now, you'll see an IP address ending in 9200 here. So what's that all about? Well, Elasticsearch provides a REST API that allows you to communicate with your cluster. And in other words, when you send requests to Elasticsearch, you're sending a HTTP request to this REST API, whose endpoint is localhost at port 9200. So if you see this IP address and don't see any error messages, we should be good to go. Now, just make sure to keep this tab open when you're working with Elasticsearch, otherwise you'll shut it down. Okay, so we just talked about how Elasticsearch provides a REST API that allows you to send HTTP requests to your cluster. So let's make sure we could send a request to the REST API. So in our second tab, I ran a curl command, which sends a request to localhost 9200. Now, if you see this response with information about our cluster and version number of Elasticsearch, that means that our cluster could receive requests. Now, in the third tab, I'm running Kibana, and this is very similar to running Elasticsearch. So CD into Kibana, which is located in your desktop, and run bin/Kibana if you are on Mac or Linux. Now, if you're on Windows, you can run bin/Kibana.bat. Now, if you're following my blog to learn how to run Kibana on Windows, then just run Kibana.bat. All right. Now, if you scroll down, you'll see that the server is running at localhost 5601. Copy and paste that into your browser. And you'll see this interface. So we just downloaded and ran an instance of Elasticsearch, also known as Node. Now, when you start up a node, a cluster is formed automatically. And the best practice is to name your cluster and node to something that is meaningful to you. And the reason you do that is because as your apps get bigger, you may be working with multiple clusters with multiple nodes that are responsible for different tasks. So it's really important that you could differentiate what each one does. Okay, so let's change the name of our cluster and node. So open up your terminal again and open a new tab. Now we're going to CD into Elasticsearch, which is located in our desktop. And then we're going to open it up with a text editor. Now you'll see Elasticsearch here, expand it, and then go to config directory. And then you'll see elasticsearch.yaml file. Now this file allows you to configure a lot of things with Elasticsearch, but for today's workshop, we're only going to focus on cluster and node. Now let's scroll down to line 17, uncommented. And we're going to change the cluster name. Now you can name this to whatever makes sense for your use case, but for our workshop, we're going to name it Elastic_crash course. Now scroll down to node name, uncomment line 22, and we're going to name this CRUD_node. Now make sure to save it and minimize it. Now, we need to stop and restart Elasticsearch and Kibana for this name changes to take place. So go back to the terminal where you're running Elasticsearch, click on the terminal, then hold Control-C. Now this is going to stop Elasticsearch, and then we're going to use the exact same command that we use to run Elasticsearch. Now it takes a couple of seconds for it to start running, so let's give that a little rest. All right, here we go. Okay, so we see the 9200 here. We're good to go. Now let's go to the terminal that's running Kibana. Click on the terminal, hold Control-C to stop Kibana, and run the same command that you used to run Kibana earlier. Now this is going to take a few seconds to load up as well. All right, great. Now Kibana is running at localhost 5601.
Okay. Give me 1 second to get set up here again. Okay. So this video just walked you through how to download Elasticsearch and Kibana and get these running on your local machine. Now, when you go to localhost 5601 on your browser, it'll take you to the home page here. So in order for us to explore the relevance of our search, we need to put some data into Elasticsearch so we have something to search for. Now, if you have your own data in CSV, JSON, or log file, it's really simple to get data into Elasticsearch. So scroll down on the home page and click on the Upload a File button. And for our tutorial, I'll be using a news category data set from Kaggle. And this data set contains news headlines from HuffPost from the year 2012 through 2018. Now, I included a link to the data set in the GitHub repo. So if you want to try this out on your own later, you know where to find it. Just make sure to download and unzip the data set. Then drag and drop the data set here. And once you do that, Kibana will give you an analysis of the first 1,000 lines of your data and give you a summary of your data set. So if you look at our file content, you'll see several documents of news headlines under different categories like crime or entertainment. And under summary, you'll also see that our data is in NGJSON format and time field is date. Now, when you scroll down, you'll see the field section. And in this data set, each document contains fields such as authors, category, headlines, and etc. And we also see some high-level statistics for each one. So scroll down and click on Import button. And this will import your data in Elasticsearch. And when we're pushing data into Elasticsearch, it'll group all documents into an index so we can easily find it. So give your index a name. I name mine news_headlines, all lowercase. Then I clicked on Import. Then Elasticsearch takes care of the rest. So you have data in Elasticsearch, and you also have Kibana up and running. And Kibana is a UI used to visualize and explore data in Elasticsearch. And for our tutorial, we'll use the Kibana console to search for data and improve the precision or recall of our search results. So click on the menu icon in the upper left corner. And in the drop-down menu, scroll all the way down to Management section and click on DevTools. And this will pull up the Kibana console. So click on Dismiss and delete the default query shown here. And now we're finally ready to get started. All right, so let me just get set up real quick here. So I have two windows open side by side. So on the left, I have the Kibana console, and on the right, we have our workshop repo. So we have two goals. One is to search for information, and two is to fine-tune precision or recall of our search results. And we'll be using Elasticsearch and Kibana to get these done. Now, we just got data into Elasticsearch, so all we have to do is to use Kibana to send search queries to Elasticsearch. So let's start by exploring our data first. So when we added data to Elasticsearch, it stored our data in an index called news headlines. And we want to get a feel for our data. So knowing what our document actually looks like or how many documents we have would be really helpful. And there's a query that gets you that information. So go to your repo and scroll down to search for information, then down to retrieve all documents from an index. Now, for every request we'll go over, I included the general syntax for you. So you could customize this for your own use case. But for our tutorial, we'll use a request shown under example. So what we're saying here is get search results from news headlines. So let's copy and paste that and paste it into the console. Make sure you click on the request. There's a dark gray bar over it, and click on this arrow to send the request. Now, what this does is it'll give you information of all documents in a news headlines index. So in the right panel, you'll see search results from Elasticsearch. Now scroll down to line 16, hits, and it gives you a sample of 10 search results by default. So let's scroll through and see what kind of documents that we have. Let's pick this one. So this document belongs to News Headlines Index. And if you look under the field source, it'll list all the fields, the content a document has. So for example, this shows you the date this article was published in, or description, the category it belongs in, headline, and etc. So with the search request, we get a general idea of what a document looks like, so we know what we're dealing with. So let's see how many documents we have this time. So we're going to go back to line 10. Now you'll see hits here. Now it tells you the total value of hits is 10,000. So by default, Elasticsearch limits the total count to 10,000. And this is done to improve the response speed on large data sets. To see if 10,000 is the exact total number of hits you have, then check the relation field below. Now, if you see an EQ in this field, that means the value is equal to total number of hits. But in our case, we see GTE, which means that our number of hits may be greater than or equal to 10,000. So let's say it's really important to us to know the exact total number of hits. So to do that, look at your repo and scroll down to get the exact total number of hits. Then down to example here. Oh. Now this is almost identical to the request that we just sent. So we're saying, hey, get search results from news headlines index. By the way, I want the exact total number of hits. So let's copy and paste this into our console. Make sure to select it and send. Now, depending on how big this data set is, this query may have a slower response time. But if you look at the results that we got back and look at the total value of hits, you'll see that the value is now 200,853. And if you look under the relation field, you'll see that the value is EQ, which means that this is the exact total number of hits. So now we know that we have over 200,000 article headlines, and we want to find interesting patterns in our data. But right now, it's just hard to know where to even start. So one way to narrow it down is to search for data within a specific time range that you're interested in. So let's scroll down to search for data within a specific time range and down to example here. Okay. Now there are two main ways to search in Elasticsearch, and these are queries and aggregations. So queries tell Elasticsearch to retrieve documents that match the criteria. And right now, we're searching for documents that match our time range criteria. So for our use case, we need to send a query. And this is a query that we're going to send. We're saying get search results from news headlines. And I'm querying documents from a certain time period. So the type of query that I'm sending is range. And the following are the criteria for documents in my search results. I want you to only look at the field date and grab me all articles that were published between these two dates. So let's copy and paste that into the console and send it. Now you'll see that we got over 8,000 hits. And if you were to look through all the search results and look at the time, look at the date field, you'll see that all of these documents fall within the time range that we specified here. Let's just look at one more for good measure. Okay, so how can we explore our data even further? Well, when we look at documents in our search results, you'll see that these articles belong in different categories like crime or politics. And to explore our data further, it'd be really helpful if we knew what type of news categories exist in our data set. So let's scroll down to aggregation section. Now remember, there are two main ways to search in Elasticsearch. These are queries and aggregations. Queries are used to retrieve documents that meet the criteria. But in this case, we're not interested in grabbing documents. What we want to know is the type of news categories that exist in our data set. So to get this information, we need to analyze the data and get the summary of categories that exist in our data. And this type of search is known as aggregations. So this time we'll send an aggregations request. So turn to your repo and scroll down to example. Now this aggregations request is pretty similar to the query request that we just sent. So here we're saying get search results from news headlines. By the way, this is an aggregations request. And I want the aggregations report to be named by category. Now I want you to run an aggregation on the following term. And that term is the field category. And bring me up to 100 categories if you got them. So let's copy and paste this into the console. Make sure to select it and send. Now, you're going to go to line 10 where hits is and click on this downward arrow here to minimize hits. Then you'll be able to access aggregations report, which we named by category. Now, if you look under the buckets field, you'll see an array of categories that exist in our data set. Now, it seems like we have categories like politics, wellness, and entertainment, and etc. It also includes how many articles that have been written under each category. So now we have more to work with. So let's scroll down to a combination of query and aggregations request. Now, it seems like the entertainment category contains a lot of articles. So let's say we want to explore that a little bit more. So what if we wanted to identify the most popular topics in the entertainment category? Now, this is a combo of both query and aggregations request, because first you got to pull all the documents from the entertainment category. So you got to query the data first. Then you have to aggregate query data and give the summary of the most popular or significant topics in the entertainment category. So let's scroll down to example. And this is a request that we're going to send. So we're saying get search results from news headlines index. Now, I want you to query all documents that match the following criteria. Pull all documents from category called entertainment. Then run aggregations on the query data. Now name this report popular in entertainment and give me the summary of the most significant text found in the field headline. So let's copy and paste that into the console. Make sure to select it and send. Now we'll go to line 10, minimize hits, and you'll see the aggregations report that we named popular in entertainment. Now, if you look under the buckets field, it'll list the most popular terms mentioned in the headlines in the entertainment category. So it seems like the word trailer has been mentioned a lot. Taylor, Kardashian, Swift, and etc. So one of my guilty pleasures is watching Keeping Up with the Kardashians. So I'm going to look up articles that mention Khloe Kardashian and Kendall Jenner. So scroll down to precision and recall, then down to example. Okay, so I'm going to send this query here. And what this is saying is get search results from news headlines. I want you to query all documents that match the following criteria. Bring me all documents that have the terms Khloe Kardashian, Kendall Jenner in the field headline. So let's copy and paste this into the console. Make sure to select it and send. Now, you'll see that there are a total of 926 hits. So let's look at the search results. If you look at the first one, in the field headline, you'll see Kendall Jenner and Khloe Kardashian. So that's pretty relevant. Now let's take a look at the second headline. Now it mentions Kendall Jenner, but not Khloe. Okay. Now if we just scroll all the way down, let's see what we got here. Okay. So in the headline, we see Kendall Jenner. However, we see Kourtney Kardashian here and not Khloe. So this is kind of relevant and not quite. Now, if you look at the next one, it mentions Nick Jonas and Kendall Jenner. Definitely that's not what we're looking for. So our search results returned a lot of articles that mention some of these search terms, but these are not perfect matches to the query. Well, why is that happening? Now, notice that our search query has multiple terms, Khloe or Kardashian or Kendall or Jenner. Now, by default, the match query uses an OR logic. So with this query, a document is considered as a hit if it contains even one of these search terms in the headline. Now, earlier, we went over concepts of precision and recall. So a question for all of you, is this query better for improving precision or recall? I want you to type the answer in the chat box. And I'll give you guys a few more seconds. All right. So you guys are all correct. The correct answer is recall. So by default, our match query uses an OR logic. So if a document has at least one of these search terms, it's going to be a hit. And because of that, we have high recall because we get an increased number of loosely related hits coming our way. Now, what if we wanted to increase precision instead? So let's scroll down to increasing precision, then down to example. Now we can increase precision by adding an AND operator. So we're using almost identical query that we sent, except that we added an AND operator. And what this is saying is only pull up documents that contain all of these search terms in the headline. So let's copy and paste that into the console. Make sure to select and send. Now with the previous query, we got 926 results. And with this one, we got 1. So when you scroll down to this one search results that we have and go down to the headline, you'll see that all 4 search terms are included in the headline. Now, this is a perfect match, so we definitely improved our precision for sure. But it feels like with our first query, we widened our net too much, and we're getting a lot of loosely related search results. But with our second query, we were way too strict and got 1 match. So is there a way to land somewhere in between? And the answer is yes. So we can use the minimum should match parameter. So let's scroll down to that section here. Now this parameter allows you to specify the minimum number of terms a document should have to be included in the search results. And this gives you more control over fine-tuning precision and recall. So let's scroll down to the example here. And this query is almost identical to the query that we just sent. So we just replaced the operator AND with minimum should match and set this equal to 3. So what we're saying here is for all the hits, at least 3 search terms must be included in the headlines. Now, of course, you can change this number however you see fit. But let's copy and paste this into the console. Make sure to select and send. Now we got 6 results this time. So compared to our last query, we improved the recall. Now, if you look at the documents, we got one here that mentions Kendall Jenner and Khloe Kardashian in the headline. Let's take another look at another one. This article has Khloe Kardashian and Kendall Jenner as well. So we got at least 2 articles that are precise matches to the query. So we improved our precision as well. So the minimum should match parameter is a way to narrow the net without being too strict. So this is good parameter to use when you're fine-tuning precision and recall. So, okay, so those are all the queries that I got for you so far. So we're gonna wrap up here. Okay, so up to this point, we looked under the hood of Elasticsearch and Kibana and learned about queries to customize the search relevance. Now, the next workshop will show you what your app could actually look like after you add a search functionality using Elastic products or solutions. So our fellow Elastic developer advocate, Jay Miller, will join us next week, and he'll show you how to build an app that searches for tech groups focused on diversity. And he'll do that by integrating an Elastic App Search solution to a React app. And he'll be running Elastic App Search on Elastic Cloud. Now, if you want to follow along, make sure to have Elastic Cloud up and running before the workshop. And the exact steps on how to do that has been covered in part 1. Now, this video has been sent to you on Monday. So just skip straight over to timestamp 2109 and follow along until 2514. Then you should be good to go. Now, this workshop is happening next Tuesday, April 13th at 12 p.m. Mountain Time. So make sure to check it out. Phoebe will be sharing how you can sign up for that event in a little bit. Now, if you have any questions about Elastic, the discussion forum is a great place to get your questions answered. And we have a community of developers and developer advocates that answer questions on this platform. So feel free to post your questions here. Now, last but not least, I often blog about Elasticsearch. So if you prefer to learn by reading instead, be sure to check out my blog. All right, so that's all I got for you. And I'll turn the floor over to Phoebe.
Hey, everybody. Thanks for joining us today. If you did have questions that we weren't able to answer, you can directly message Lisa in the chat with your email address if you'd like her to reply back to you to answer your question specifically. And then let's definitely get you registered for part 3 of this series and a swag drawing. So grab this QR code. Part 3 is happening April 13th. We're going to be creating a diversity org application. So if you want to find diversity organizations and learn how to make a fast React and Elastic app, we will be doing that with Jay Miller, another of our community advocates. And the swag could be all different kinds of things. So water bottles, stickers, things like that. And again, this session will be recorded. We will be sharing the recording out in a follow-up email along with other resource links. And I've shared quite a few links in the chat, so be sure you comb back through that chat and take those out, link to them. And we hope that you all have a great rest of your day or evening, and really appreciate you joining us from wherever you are joining us in the world today. And that's it for me.